Hello class, this lesson we're going to learn about the law of cosines. So we're really going to be focusing on just the so here, sine is opposite over hypotenuse. So we use it on triangles that are not right triangles. So sine is useful even though we don't have a right angle. And here is the law. So you have the sine of angle A over A, that's the same as sine of angle B over B, which is the same as sine of angle C over C. Remember, these are the lengths of the sides opposite each corresponding angle. So I'd like you to take a moment to try to restate this law in your own words. Make it pretty general. How would you restate this? So here's one possible answer. The ratio of the sine of each angle to the opposite side is always going to be the same in a triangle, no matter which angle you start with. So why is this true? Let's go through a quick little proof. So sine of angle C, how can we write that if we have this altitude dropped here from B? Well, sine is opposite over hypotenuse, so that would be h over a. So if we use the cross product, h is a times the sine of angle C. What is the sine of angle A? Similarly, you would get h over C. And if we apply the cross products, we have h is C times the sine of angle A. So what can we say now? What can we do with our two equations? So how can we combine them? Looking at this one and this one. Well, we can use substitution and say that those quantities are equal to each other. Right? This is just applying the transitive property of equality. And if we divide both sides by a and c, we end up with this equation. Right? If we divide by a here, the a's cancel, and you get the a on the denominator here. Divide by c, and those c's cancel. You get the c in the denominator over here. So we really just divided both sides by ac. So we have part of the law of sines. What else do we need? What else do we need here? Well, we got to get b involved somehow. Right? We got to say that sine of b over b is equal to one of these. So now we have a different altitude drawn. And if we look here, the sine of b is h over c, or we can say that h is c times the sine of angle b. And as before, we can do the same thing with angle c. And the same idea, divide both sides of that equation by cb, and you end up with this. And so by substitution, we end up with the law of sines. So that's nice. Now let's go ahead and apply it. So here's a problem. We have these two angles and this distance, and we want to figure out the distance from A to B. So what can we add on here? What measurement can we add on the diagram? Well, we know that angle B has to be 84 degrees. And let's label our opposite sides appropriately. Right? If this is angle A, this must be little a. Angle C, it's got to be that little c. And use the law of sines to set up all the possible ratios here. So here is the law of sines. I'd like you to try to substitute as much as you can into this formula. Try that on your own. I'll show you my answer. So hopefully you have something like this. And when we know it's clear in the context that we're talking about degrees, so we don't really have to write the degree symbols there, but they're implied. And so which ones will we use to figure out the distance from A to B? So distance from A to B is C. That's length C. So you have to get C involved. We don't want to have more than one variable. So we have C and the sine of 55. We got to use this one in the middle because this doesn't have any other variable in it. Right? If we use the first one, we get stuck with that A. So we can solve this. So go ahead and solve that for C. Make sure you're in degree mode, and then I'll show you my solution. So you apply the cross product, and we want to divide by sine of 84. And you plug that in the calculator, and you get that number. So be careful here. Once again, make sure you're in degree mode. Degree. And we have 160 times the sine of 55 degrees, close your parentheses, divided by the sine of 84 degrees. And we get that number. Round that to the nearest meter, and we get about 132 meters. So that's how we can use the law of sines to find a missing distance. We can also use the law of sines to find a missing angle. So here they give us some information. I'd like to first draw a diagram. Then we're going to figure out what the sine of angle B is and ultimately the measure of angle B. So here's my diagram. And let's set this up using the law of sines. So we have the sine of 30 over 12. That's got to be the same as the sine of B over 10. Right, and we can flip that around because equals is symmetric. Okay, now we use the cross product. So we want to get sine of B by itself. So we get the opposite of multiply by 12 is divide by 12. And luckily, the sine of 30 is just 1/2. Right, we learned that from our 30, 60, 90 triangle. But if you didn't remember that fact, you could always double check it here. Sine of 30, 0.5. So this works out to be 5/12. So that's sine of B. Now how do we figure out what the measure of angle B is? To the nearest tenth of a degree. Well, now we just have to apply inverse sine to both sides. So what's the inverse sine of 5/12? 5 divided by 12. About 24.6 degrees. That's how we can use the law of sines to find a missing angle. So we have an application. They give us some information on here. We got a 30-degree angle here, 45-degree angle here, a right angle over here. I want to figure out what's the height of the hill. Well, they only give us this 250, which is a distance from A to B. So that's a part of this obtuse triangle over here. And H isn't a part of that. So H is going to have to go to the side for a moment. We want to figure out what is this length right here, because that's a hypotenuse of this 45, 90 triangle. So if we can figure out the hypotenuse, then we know how to find the length of the leg. Just divide by square root of 2. So how do we figure that out? Well, we know this is 45, and that's 90, so this has to be 45 in there. And that's 30, and that's 90, so this bigger angle must be 60. So this little sliver in here, this little angle must be 15, because 60 minus 45 is 15. So now we're looking at this obtuse triangle, and we know that we have that 15 degrees, 30 degrees, and these corresponding side lengths. So we can use the law of sines here. So we have the sine of 15, talking about degrees, over 250 is the same as the sine of 30 over x. So we apply the cross product. And we're going to divide both sides by the sine of 15. And you plug this whole expression in your calculator, and we end up with that number, 482.962 about. Sine of 30 divided by sine of 15. Don't forget to close your parentheses after your degrees, your angle measurements. And we get this number. So that's how you can use law of sines to find a missing side, but we didn't answer our question. We want to figure out what is h. Well, we got the hypotenuse of 45, 45, 90. And we know that if we multiply the leg by the square root of 2, we get the hypotenuse. So we just got to divide by the square root of 2. So don't round your number too early. So when you take this previous answer, you can either store that as a variable or just hit the divide button to input your previous answer. Divided by the square root of 2. And we get about 341.506. So we round it to the nearest tenth. I'm sorry, not nearest tenth, nearest foot. I believe it says up here. Yep, to the nearest foot. And we get about 342 feet. All right, in this lesson we learned how to apply the law of sines. We have it as a little refresher. Thank you for watching this video.